One useful thing to know how to do in math is to classify numbers as into certain types of categories: prime, undefined, real, imaginary, and so on. That will definitely come up if you're taking a standardized math test or anything that's measuring your knowledge of high school, junior high algebra. I'm going to go through these numbers over here, and let's see which ones match the definitions on the right. Everything on the right is present in at least one of these numbers. Some of them are present in a lot, some of them not so much. Let's see what we've got. Prime numbers. That's anything which is only divisible by itself and the number of 1. So 11, for example, not the number 1. The number 1 is not a prime number. That's a common mistake. So we skip that. The number 0, right here, that's not prime. Okay, it has to be greater than 1. And I'm looking at the rest of these. I don't see any other prime numbers, just the number 11. Maybe I made a mistake. Maybe I missed something. We'll see. Undefined. Undefined has a very special meaning. It means you divided it by 0. So that's easy to see. There's no more of those. In terms of real numbers are anything, I could say not imaginary, but that would be circular. It's anything that you could use to measure, like temperature or money or something like that. So I can see a few numbers here that are real, quite a few numbers that are real on this list. Basically anything that's not square rooting and negative. Ugly numbers are fine. All these things that I've listed are real numbers. Some of them are not real numbers. So for example, this is some kind of an imaginary term. It has a square root of a negative in it. This includes an imaginary term, the 8i. Okay. In terms of imaginary, and that means purely imaginary, there's only a very few things on this list. I think that's it. Square root of negative. That's the only purely imaginary. This, although it has an imaginary term in it, the 8i, is not purely imaginary because it has a real part. Complex numbers are anything that has real and imaginary parts to it. So there's quite a few of these. 11 is complex. It just has a 0 imaginary part. 1 is complex. It has a 0 imaginary part. This thing's undefined. It's going to be very unpopular with this list. There's really not many words to describe it. But we've got a complex number here, here, here. You might think, well, wait, I thought that was just imaginary. It is, but it has a 0 real part, so it counts as complex too. A lot of complex numbers on this list. And finally, the one that people would probably notice first, this one. This is complex because it obviously has a real and imaginary part, as opposed to all those other ones which had a real part and maybe a 0 imaginary part, or vice versa. Integers or whole numbers, those are easy to spot. Okay, anything that looks like you would count it when you're counting numbers. 0 is an integer, but fractions are not integers, square roots are not integers. Rational numbers are anything you could write as a fraction nicely. Okay, so this is not a rational number. Even though I can write it as a fraction, it's undefined. It's not an actual number. So I can't call it a rational number, even though it does have an integer on top, integer on bottom. But this one, right here, is rational because it's 0 divided by 11. That's a fraction. And more importantly, not only is it a fraction, but it's a real number. 4/3 is rational. These square roots right here, we got to be very careful about these. First of all, this one's imaginary, and nothing imaginary can be rational. This one right here, you might think, whoa, that's a square root. That's not going to be rational. But if you simplify it, you'll realize that this is just equal to 4/3. Okay, and that's rational. Okay, 3/9, not so good. If you simplify that, the best you can get is square root of 1/3, and that is not rational. Okay, so there's my list of rational numbers. Now, irrational numbers are things that you can't write as a fraction. So there's not very many of those. Looking over this list, first of all, this is not irrational because it's not even a number. It doesn't exist. But there are some things on here that are irrational. I think one thing on here, actually. There we go. So I might have missed something. Who knows? Maybe I made a little typo somewhere, but you get the general idea. Snapshot these definitions over here on the right. I think these would be very handy for you to have written down somewhere. You never know when they might come up.